This video is about a second popular type of clustering called k-means clustering. So as you will recall, clustering is about defining things that are close together and then grouping those things into groups that are close as based on that distance. And then we might want to visualize the grouping or interpret it so that other people can understand the clusters that we've observed amongst our variables or observations. So remember that the important thing is to define close in an appropriate way. If you have garbage in, you'll get garbage out. In other words, if you pick a bad distance metric, obviously your clustering will also be bad. In this case, we'll primarily focus on the distance, continuous variable distance, Euclidean distance for clustering, as that's the primary distance that's used in k-means clustering. In this case, we need to pick a distance that corresponds to quantitative variables, so usually k-means is applied to a set of quantitative variables. So k-means clustering is a little bit different than hierarchical clustering in that it's a partitioning approach as opposed to an agglomerative approach. So a partitioning approach starts with all of the points and tries to divide it up into a fixed number of clusters. We have to fix the number of clusters in advance and then guess as to what the centers of those clusters might be. We then assign things to the closest center or centroid of the cluster, and then recalculate the centroids and iterate through this approach. It requires a defined distance metric, a number of clusters, and an initial guess as to the cluster centroids. The most particularly important thing to pay attention to is that the number of clusters must be defined in advance for k-mean clustering. So what people sometimes do is start off with a large number of clusters, apply k-means clustering, look at the clusters and see if they're sort of reasonable, and then reduce the number of clusters. What you get at the end is a final estimate of the cluster centroids, or the centers of the clusters, and a hard assignment of each point to each of the clusters. Each point gets only one cluster assignment without sort of any potential variability across clusters. So the k-means clustering example that I'm going to use is the same as the hierarchical clustering example. I've generated 12 points that cluster approximately into these 3 different clusters. And so we're going to use these to show how the k-means clustering algorithm works. So the first thing that you do is you assign some starting centroids. So in this case, I know there are 3 clusters, so I'm going to start off with telling k-means that there are 3 clusters that I would like out. And then I say the starting values of the centroids of those clusters, or the centers of those clusters, are these different crosses, the purple cross, the orange cross, and the red cross. So the first step in the k-means clustering algorithm is to assign all of the points to the closest centroid. In this case, the closest in Euclidean distance. So points 4 and 8 are closest to the red cross, these purple points are all closest to the purple cross, and these 3 points are all closest to the orange cross. The next step in the k-means clustering algorithm is to recalculate the centroids. So what I do now is I take the 2 red points and I take their average x value and average y value, and I get a new center for this cluster. Similarly, I took all the purple points and took their average x and y values to get a new purple centroid, and the same thing for the orange values. Once I've done that, then I can recalculate the distance to each of the centroids for each of the points and reassign points to the appropriate centroids. So in this case now, all of these orange points correspond to this centroid, these 2 red points correspond to the red centroid, and these purple points correspond to the purple centroid. You then iterate this procedure by updating the centroids again, and so now you can see that this purple centroid is getting very close to this cluster over here, this red centroid is getting close to this cluster over here, and this orange centroid is getting close to this cluster over here. So if I then reassign the points, I'm going to get all of the red points will appear in this cluster, all of the orange points will appear in this cluster, and all of the purple points will appear in this cluster, and I'll have clustered the data according to a k-means clustering. In R, you can perform k-means clustering with the k-means function. So it'll take either a data frame or a matrix object. So in this case, I'm going to pass it a data frame with the x and y values of the variables that we're going to be of the observations that we're going to be clustering, and then I perform k-means and I give it the number of centers that I'd like to consider. Alternatively, I could tell it in advance what I think those cluster centers are, so I could pass the centers variable the centers of the actual clusters that I'd like to consider. I should also tell it the number of iterations it should perform at a maximum. So if it's not converging, you may end up with sort of a long k-means operation, particularly for large data sets. So right now the default I think is set to itermax equals 10, but you can up that if you want to allow it to iterate more. And then you might also tell it the number of starts. So it turns out that the k-means algorithm is actually not deterministic. If you give it the exact same data with different starting center values, it may actually converge to a different set of clusters. So you might allow the k-means algorithm to restart multiple times and get sort of an average cluster across multiple starts. What you get out when you perform k-means clustering is an object, and it tells you the clusters, the centers of those clusters, and then some information about how variable those estimates of those clusters are. And so the cluster component of the k-means object tells you which cluster each data point has been assigned to. So the first data point was assigned to cluster 3, as the second and the third and the fourth, and then the 5th through 8th points were assigned to cluster 1, and the 9th through 12th points were assigned to cluster 3. This is good because they were generated such that the first 4 points came from one cluster, the next 4 points came from the next cluster, and so forth. So if you make a plot of the values that you observe out from the k-means algorithm, you can actually see the data points that we originally had, and the cluster centers are indicated by these the crosses, and the colors represent which cluster each point is assigned to. And so you can see in this particularly simple case, k-means was able to assign each of the data points to the correct cluster. In general, this won't always be so simple or clean as this, but it's nice for an illustrative example. You can also visualize the data itself after performing a cluster analysis. So again, what I've done here is I've created this data matrix, but now I've scrambled the order of the rows. And then what I do is I perform k-means clustering on the scrambled matrix. And then I can plot the actual quantitative values for both the scrambled version and the unscrambled version of the data set. So in the scrambled version, I see 2 columns in this heat map. Each one corresponding to the, in this case, the x values and the y values in column 2, and then each row corresponds to one of the points. And you can see that they've been scrambled up here on the left. And then on the right, they're slightly more ordered. You can see that they've been kind of clustered into specific types of patterns that you see in the data. And so I've done that by reordering the data set according to the k-means clustering ordering. And so that's the way that you can actually visualize the data themselves. Some further resources and notes. So first of all, you have to know the number of clusters in advance to run k-means clustering. One approach is to sort of pick by eye or intuition. Like if you had looked at that very early example plot, you can see that it looks like there are about 3 clusters. You could also pick by cross-validation or information theory. I've linked here to an article about determining the number of clusters in k-means clustering, but there's actually a huge literature on this, and it's worth a little bit of a Google search if that's something that you need to learn about. K-means is actually not deterministic, as I've mentioned, so you get for a different number of clusters or a different number of iterations, you might get actually a different k-means output. In fact, if you use the exact same points but you use different cluster centers and you rerun the algorithm the same number of iterations, you may actually get different clusterings. So again, I've linked here to Rafa's Distances in Clustering YouTube video, which gives an example of this clustering algorithm and gives some more information, as well as the Elements of Statistical Learning, which has much more mathematical detail about the k-means clustering algorithm.